on this computer. So just to go and remind you what we're doing this week and how we're progressing with against the course outline. So to find the course outline, you come to the welcome. This is the PDF file where it says the course outline. I'm just sharing my screen again to make sure. You click on that document and you can go to the schedule, weekly schedule, and see what we're doing every week. So we are week 6. This week we have 2 things. We're starting a new topic, CFD Internal Flows. We'll learn how to go to the CFD analysis, and then we'll start with the as well how to find the results, how to get the results. And also reminder that your assignment 1 is due this 25th of March, tomorrow, 11 p.m. So if you are on time, please submit everything to Moodle, and we can follow. You can follow the marking guide for instructions. Right. So that's just a reminder for what we've been doing this week. So we go to FEA and CFD analysis tab, and then you go to CFD internal flows. So in this week's session, we will navigate the SolidWorks flow simulation environment. How can we set it up? If you haven't done it before, we'll do it one time on your computer or even on the desktop. We will learn how to define boundary conditions for the CFD analysis by applying the right setup, if it is internal flow or external flow, laminar turbulence or laminar to turbulence, include or exclude cavitation, include or exclude temperature, so adiabatic system or isothermal. Also another physical properties. We set goals for the CFD analysis. Goals mean the things we want to monitor, such as the velocity, the pressure, temperature, whatever involves that flow. And then we run the CFD analysis of an internal fluid flow in a structure. And then after that, we'll wait till the results being calculated. We visualize them, and we explore how can we plot some of the information for us, like to go through it. So I'll start with a demo. And then from the demo, I will give you some activities like the valve analysis as a good example. In class activity, you start working following. There is a level nozzle analysis as well, mixing flow analysis activity, heat exchanger efficiency, and good examples like if you want to include the temperature, mixing 2 fluids, cold and hot, and how can you mix with them. So I started the software, but I will go from the beginning again. So I'll close everything to make sure you start with me. This is the SolidWorks, the 25 I'm using here. To start with any analysis, Control N, parts. I'm doing single part at this level, very basic example. I always like to set up my background to plain white, and that will be easy for me to visualize the results. First, because I don't have the geometry, I cannot start with the flow simulation. But before we're going for everything, I must activate flow simulation. So you come to that gearbox at the top. You cannot see it here. I'll make it sure you can see it here. Do you see that gearbox? And then from that gearbox, you click on that arrow, and then you locate add-ins. And then from add-ins, these are the extra things which we get with the student license. In the previous simulation, FE analysis, we ticked these 2 boxes for the SolidWorks simulations. Now for the flow, you come to SolidWorks add-ins, and you can see I need to tick these 2. SolidWorks Flow Simulation 25, make sure to tick both of them. It's recommended if you're not doing CFD, you untick these boxes to reduce the processor or the space of the software, so to not overcrowd your SolidWorks and to avoid crashes. But since now I'm using it, I will activate that for both of them. So by default, you find these boxes are unticked. Now what I want you to do is to tick these boxes. When you click OK, the computer will take a time to refresh itself. It doesn't happen to me because I already had it clicked. And then we will see that tab here is called Flow Simulation. It's kind of giving you new options to run the CFD and everything. So that is just to get it activated. I'm not starting with it yet. I'll first start with creating the geometry, and then we go through it. So if you have any question, I'll pause here. If how you can get the flow simulation activated on your computer. If you have any question, please ask so I can come and help you how to get it activated.
Hey, Mohammed, could you please repeat that? I didn't quite catch it.
Okay, Clint. So that's good. So I will deactivate that, and then I'll repeat it how to do it step by step. Okay.
Yeah.
Okay. So first of all, I just remove it now. So see, add-ins. I didn't. I thought I removed it, but it obviously didn't. Okay, remove now. So when you come to the CFD analysis, you will search for that kind of like a gearbox or settings. You click on the arrow and you go to add-ins. From add-ins, you go down. If you have the SolidWorks license for education or for students, then you should get all these add-ins. Make sure you accepted this in the installation. If you don't, then you need to reinstall and add that in the installation. But if it's installed already, you click here and here. That's mean these two will start the startup and the loading time. They will take about 7 seconds. As soon as you start the SolidWorks, that's why I say it will load or will delay if you're not using it, but now I'm using it, I need to add it. So I ticked here and I tick there. And then I click OK. Do you have it, Glenn, in your computer?
Yeah, we only had the 2024 though. Would that be
Doesn't
fine?
matter. Doesn't matter any version you're using. Okay.
Yeah. So that solid composer, I don't had that.
You don't need that. I'm just focusing on this one at this stage.
Yeah.
SolidWorks flow simulation. I didn't mention SolidWorks composer at all. Okay.
Yeah.
Okay. Cool. Just follow what I'm saying. Okay. So you tick that one and that one. Okay. And then you click OK.
Yep.
And then you see, because I removed it and now bring it back, will take time to refresh. The computer starts suddenly, or software start refreshing itself. And it takes about time. See, very soon, depends on the processor of my computer. If it didn't happen, like my situation, I'll go and check again. Did I click it? Yeah. It's camps now here. So you can see it here. It show up that tab here. It's flow simulation. When I click on that tab, it give me all these options to set up the CFD analysis. Have you got it there, Clint? All good?
Yeah. Okay. My one works. Yeah.
Okay, that is the first step. We just want to set it up. We're not doing anything there. Now I go back to sketch, to the sketch tab. So I want to sketch my geometry or the body we're trying to go. So basically what I would do, I would sketch a pipe, and that pipe, I want to make sure the flow would go inside that pipe. So under sketch, I would choose the right plan or front plan, or choose the front plan. And then from that front plan, I'll make it normal to face me. In the sketch, I'll choose the circle. And from the origin, I will go with that dimension. I ensure I'm working in mmgs, which is millimeters units. With the smart dimensions, I would just make sure that it's equal to 20 millimeters. So again, to repeat that steps, I selected the front plan, go and select the circle, draw the circle from the origin of the SolidWorks, and then add with using smart dimensions a 20 millimeters diameter. Happy with that, I will click exit the sketch. You can see it here because I'm done with my sketch. And then I will go to features. You can, by the way, avoid exit sketch and go to features quickly, but I prefer you go to exit sketch and you use extrude boss. You extrude will ask you which one. Select the circle again. Yes, Glenn?
Can I please interrupt you quickly? So on my SolidWorks, the units for mine was an inch. How would I convert that to millimeter?
Okay, you're missing a lot, Glenn. So you come to this corner here, and then you
Yeah.
change that from, for example, you are in IPS system to millimeter
Yeah.
system. Okay, Clint?
Yeah, sweet. Got it. Cheers.
All right. So I extend that, extrude. I will look into the direction, see it's Z is going that way. And then I'll extrude that. Let's say I'll give it 1000 millimeters. I want it to be too long. So it's kind of like 1 meter. And you see it's going in the Z direction. If I want to reverse it, you just click reverse, but at this time, I'm just going it with the Z direction. Click OK. So we created kind of like a pipe, let's call it, with 20 millimeters outside diameter. Do I repeat that? Happy to do that again. So delete, extrude. After I finish my circle, I go to extrude it, or to convert that to the drawing. I select, by default is going to that direction Z. I put the value 1000 millimeters, and it will create for me a pipe with 20 millimeters outside diameter, and the length of that pipe is 1 meter or 1000 millimeters. We're working in millimeters, so it's best to stick that number. And then I click OK. It generates for me this 1000 millimeters pipe. Now that pipe, I need to have thickness for it to make it through like hollow, the thickness. So to create thickness, very simple. There is an option, it's called shell. If I say something and you cannot see it, you always can go to the command window. I'll put this down. You can type here and click on shell, and you can see as soon as I put the 3 first 4 letters will help me to allocate it. But I know because I use shell a lot, so I know where is it. But for you, if you first time, where is shell? And you can use it from that way. And you can say, show it to me, and we'll end it like you find that SolidWorks showing you the red arrow to tell you where is that shell, which is very helpful to be familiar. How can you allocate these commands? So again, if I want a shell, just make sure to click on that eye. And if you want a sheet metal, see, I put, if I'm looking for sheet metal or shell or assist publisher or whatever things, it will say. So I'm not able to allocate that assist publisher as an example. When I click on the eye, you can see the software is telling me my hands is off and showing me where can I find it. And that's a very useful for us to allocate these things when we go and search. Okay, for me, it's the shell here, easy. So I zoom up. When I click on shell, will ask me what you want to shell and what's the parameter we want to shell. So I want to create an internal diameter. So my external is 20. I want to reduce from the 20 2 millimeters, and which faces this one and the other face. So I'm selecting not the out surface of the pipe, is the in and out of the pipe. What that mean? If I'm doubting myself, SolidWorks allows you to click on show preview. That is to preview what's exactly you're doing. Now, if you want to do that shell outward, you click on outward. It's mean my outside diameter became 22. But I'm not interested to shell outwards. I'm interested to shell inwards. It's mean the 20 millimeters minus 2 millimeters, my internal diameter, it should be 18. Is it 18? We'll check that. If we doubt that, always you can use dimensions and go through it. Okay, so now the other option here, it's allow you if you want to have it tapered. So the inlet is 18 millimeters and the outlet you want it to be 10 millimeters. So you have it gradually smoothing from big inlet to smaller outlet. That if you wanted to have 2 different in and outlet dimensions. At the moment, we're sticking with a simple example. Both faces, we select them. As soon as I'm happy, I click OK, and that will create for me a pipe. I can see through it, and very simple pipe. Now, if you learned from fluid mechanics to study anything, I need to have like what we call it a water geometry, watertight geometry. It means SolidWorks needs to understand where is the boundaries of the fluid, where it's coming, where it's leaving. It's kind of like a closed system treating it for internal flows. So I will show you how to do that when we start with the CFD, because this is just an open pipe or tube, but we need to go through it. So as soon as I finish, I need to save. Again, FEA, CFD files, they create big data. And CFD even creates bigger data than the FEA. So I'll go File. For me, I'll save it on desktop so I can delete it later. I don't need this. So Save. And before I save it, I create a new folder. I call it week 6, right? Week 6 CFD example. I'm saving it on my desktop because I will delete it. For you, please save it where you can access it again. Please note the following. SolidWorks CFD simulation doesn't like the cloud. Hates the cloud. It needs the drive of the computer. So I always save it in desktop and then copy paste, zip it and copy paste it to your computer. Okay. So I created that folder, double click on it. Part 2, I'll call it pipe. Just give a name. So instead of part 2, let's be more specific. It's part of the engineering communication tools. It's naming the files correctly. Okay, happy with that? Save. So if I check that on my desktop, you will see, did I save it on my desktop? I forgot where did I save it. I thought I did. Okay, let's see where I've saved it. File, save as.
And this PC, yeah.
No, I undownload. I did it undownload. It's fine. So when you go to download, you can see it's only one file there. When we do the CFD, you see many, many files generated. That's why I strongly keep everything in one space to avoid any confusions. All right, we come back. Now I activated the flow simulation earlier. Click on flow simulation. You see now we entered in different space. First of all, this geometry is not watertight. So you see those tools here? And from tools, create lids. So again, if I don't know how to find create lids, I will search here, create lids. And you can see it. I click on the eye and will show me where is that create lids. I can find it. So see how it goes to tools, from tools, flow simulation, again, tools, and then create lids, and very nicely is showing me where that create lids. However, by default, I know they are here as well for me. With the 25 version, they made it easy to access it. But if I'm using 24 version, you go to tools, and then flow simulations, tools again, create lids, that is the pathway for it. If I'm confused, I just search in that and you find it. Okay, so I will go with the normal, like I'm having 24 version or 23 version. Click create lids. The software will ask me where do you want this list to be created. So what I will select, I water tie the tube or the pipe. So I will select that thickness, and I go at the back. I select that thickness, and you see nicely generated for me those blue. I'm just zooming out. Those two lids, kind of like lidding it. Put a lid on it to watertight it, so if the fluid inside will be treated. And these lids are very important to set up our boundary conditions. Without them, my boundary conditions will not work for internal flows. So you see phase 1 created, phase 2 created, and I click on OK. You see by default here is created for me imported and imported. I created 2 lids by default. Okay. I'll repeat that step. If something it's not easy, I will redo it. Delete. I'll repeat this lidding stuff. So I want to watertight this pipe. Go to here, tools, flow simulations, tools again, create lids. And when you open, ask you what to select. I'll select that thickness, and then I rotate it, and I'll select the other thickness. And then you can see those two blue lids applied for my pipe, and I'm happy with that. I click OK. All right, so now my pipe, it's watertight geometry. I cannot see through the pipe, so there is an option SolidWorks offers you. Right-click on the pipe on the top of this tree, and then you can click on that top-level transparency, which allows you, still you can see it. I'm not hiding it, but I'm reducing the transparency of the object, so I can see through. Allows me to see what is happening inside the things, but I haven't like hiding it. So when you hide it, this mean would not be taken into consideration, or you excluding from the simulation. Hiding is just temporarily hide. If you want to exclude it from simulation, there is an option. We'll see it later. At this moment, we cannot do it because we have one part. But I can do it, for example, this one. Suppress is mean I'm not including this in my simulation, but I'm not doing it here. Okay. Now, SolidWorks has a magic tools. And you can see it here. If you like Harry Potter, they have the wizard. The wizard can do everything for you. So now we will start the CFD analysis. We click on wizard. The project, I know the part is what's called pipe, but the project we're starting as a new, we call it pipe. And I'll call it laminar flow, underscore laminar flow. So yes, the part is called pipe, but now I'm renaming the project, which is related to CFD analysis. As soon as I click next, but before next, if you want to configure anything you want, select. At this stage, we're just working with the default. Next, I'm working with the SI system units, which is meters, kgs, seconds. And also SolidWorks allows me to change how many displacement I want to show. If I want to show the length in millimeters, I can just come here and change that, but I'm not changing anything at this stage. I'm keeping everything in meters. Temperature, you want to change it to degrees Celsius. I'm not doing temperature on this model, but that's where you can change anything you want. Okay, so I'm keeping the units SI by default. Next, fluid flow. Convection, no, I'm not having any convection. Time dependence, no, is a steady flow, so I'm not doing transit analysis. The pipe, if you look at it, it's going through that way. The Y, positive Y is upwards, so I want to include gravity. If I include gravity, click on the gravity. By default, it's telling me the gravity is in the Z direction. You can see the arrow here, which is wrong. That value should be 0, and the Y should be minus 9.81. Now, when you see the gravity is downwards. So that is just telling me this pipe is following that orientation. So it's lying on the ground, and this is the gravity of it. So 0 is the X component, minus 9.81. The minus is the direction. It's very important for us to know how we set up that. And 0 on the Z because I have only one gravity direction. Okay. Analysis type, we're using internal flow. That's the first thing. The week later, we do external flow. And exclude cavities with without conditions. So we're not taking any cavitations here, cavities. So internal. Then next. We need to add the fluid. So at this stage, I will assume the fluid is water. So you see the tree, you have gases, you have non-Newtonian liquids like blood or whatever, or something like storage system. If you're working for civil engineering, water and wastewater, so the storage system fluid coming, it's actually non-Newtonian. So you need to give it that properties. For us, we use the liquid. So I expand that, open that plus, and search for water. And you have two options. Either you click on add, or you double click. Both of them, they would do the same thing. If I want to remove, change my mind, I say I don't want to add water, you can remove here and re-add that again. So very simple. I could add a mix of fluids. We'll do that later. Flow type, we say this is laminar, so I say laminar only analysis. Okay. Cavitation, I'm not including cavitation at this stage because it's just straight pipe, so it's not like a valve. In valves, it's very important to address cavitation because cavitation is one of the things could impact on the valve or the pump as well. So I would say next. Here, default wall thermal conditions. Adiabatic is mean there is no heat loss in the system. I'm not concerned about heat, but you have options: heat flux, heat transfer rate, or wall temperature. At this stage, we don't have anything. It's just a tube, water passing through it at room temperature. Micrometer, that's very important. That is the roughness. So you remember when you used to perform with Reynolds numbers to go and work with Moody chart? We need to know if this is a plastic or this is a galvanized iron or this is a steel or whatever. The inside of the pipe, if it's smooth, you get the value, whatever it is. So I would choose something 0.04. Let's say it's not really new pipe and has some relative roughness. Okay, next. Next is the initial boundary conditions. So I'm telling the software, this system is starting with 0 velocities, with normal pressure, which is atmospheric pressure, the 101, 30, 325 Pascal, and also room temperature, which is about that if it's 293.2 minus 273.2, which is about 20 degrees, I think, 20, yeah, degrees, which is the room temperature. And I'll keep them because at this stage, I'm starting like everything is constant, 0, 0, 0. That is mean I set up my geometry, and very soon you will see the window here will take me to CFD as soon as I click finish. Finish, you see now the software is doing its own calculation to start preparing. But because my software has problems, I encounter issues. I love this software. That's the installation possibly. And lovely, my software's crashed. I didn't save. That's another problem. Did it crash for you or just me? It's my computer. I think because I'm using the Zoom and it's over. I think Zoom, Teams, everything is open, so it's crashing for me. That's what I've been experiencing in the last 5 weeks. The processor is struggling. So for you, should be fine and should be just worked with starting it, the Windows. I'll try to do it very quickly. Challenge to do this, to repeat everything in 1 minute. Oh, so the geometry is saved, but I haven't saved the CFD. Let's see if it's saved, whatever is saved. Close this one. Okay, so I'll do everything very quickly now. So let's create lids. This and this. Okay. And then wizard. Pipe. Flow. Next. This unit system, okay, its flow gravity is minus 9.81, and this one is 0. It's internal flow. Okay, next, the liquid is water, and it's laminar only. Next, 0.04. Next. Finish. Hopefully it doesn't crash again. Okay, good news, didn't crash. Okay, so yeah, now that's what I was mentioning before. It would generate for you. Now we enter to a new addition to the software. You can see that is the sample of SolidWorks simulation. It's always, that's where I can understand there is simulation. This is the first study. In the FEA, remember, we used to have the new studies here next to the motion study. Remember, static 1, static 2. In CFD, they are here. They will be on the top. And every time if I want to copy, right-click, and I use the clone. The clone is the copy, means I'm copying the study to change things from it. So this is my my domain, but I need to explain things before we start. If by default, I made a mistakes in my settings with the wizard, and I want to change that, you come to input data, right click, and click on general settings. It takes me back to my setup. So if in case I made a mistake and I was like, I made this, I did the gravity wrong, or I did something wrong, you can always come to input data, general settings, and you can fix that. Okay. Computational domain. What's computational domain? I need to explain this, very important for CFD modeling. So when I review papers, if I see someone didn't submit this computational domain, I really get really upset, even in your assignment. Computational domain is just to let the person understand this is where is the fluid or the CFD tool software is solving the problem. This is the boundaries of where we need to take into account where is my inlet, where is my outlet, where is the fluid is passing. So I have water here, and this is where everything. Which one is representing for us that rectangular shaped box? That is the computational domain, okay? I can enlarge it by those arrows, but because it's an internal flow, I don't need to do that. It's already detected by the software. If I want to give values as well, instead of doing it manually, its software allows you, if you double click on computational domain, to give you the X positive and negative directions, and Y and Z to expand that a cubic to make sure it's relying nicely with the computational domain. So if that cubic was smaller and my boundary conditions are outside, the software will give me a warning to say, hey, your boundary conditions are not within the computational domain. I cannot solve this problem because it's outside the computational domain. Computational domain is where is my problem should be solved. Everything should be inside it. Okay, so let's select boundary conditions. What I would do always, I explained this boundary conditions. So this is where the fluid is going. I have a velocity from that face and velocity and pressure opening on that face. But I don't like that face. I'll go back. I want to go back to my geometry. See where I'm going? The arrow. And I go to geometry. I will change that from transparency, okay? And I'll right click on it and I'll hide it temporarily. Okay, so what I did, I made it transparent to see through. I unclick that to go through it. And now I come here and I say, hide this. I only want to see the lids. So now you see when I had it, I just see the lids there. Okay, I go back, arrows, see the arrow where I'm going to search for my computational domain. That's the nice way to move between the geometry and the things. By the way, you can do this in the tree. You can bring, there are multiple ways, but I'm showing you the simple way, easy way. Why I need that? Because based on that, I need to ensure my computational domain, when I select my boundary condition, that face is actually covered with that cube. So I'll come first. Fluid boundary condition. Right click on boundary condition. Insert boundary condition. Will ask me, what do you want to insert? First, I need to select the face. This is the face. And I select from it inlet velocity. And then the value for that inlet velocity, very small, 0.01 meters per second. Okay. So I have multiple options. I could select inlet mass flow rate, inlet mass flow flux, like if that is a heat with it, inlet volume flow, so like Q meters cubic per second, or inlet velocity. So always we have the inlet, and then the other one is the outlet. As soon as I click OK, you see the direction of the arrows. So see, I click OK. It's showing me those red arrows as an inlet boundary conditions. That is where the water is going, will start moving. Okay. And that's the arrows mean I have a boundary conditions here. And also they name here as well, inlet velocity 1. Now I zoom out by screwing the middle to go to the other one. This is the other one. Nothing is selected there. I go again, right click on boundary conditions, insert boundary conditions. By nature, we always use the following. At the inlet, we use inlet velocity or volume flow rate or mass flow rate, 3 options. At the outlet, we use pressure. Because it's open pressure, how is the pressure? We go in that middle one, pressure opening. It's mean a pipe is open at the end. So water comes like a hose for the garden. Okay, so there is a static pressure or total pressure. I will use environmental pressure. What does mean environmental pressure? It's taking the atmospheric peak gauge is 0, so only atmospheric pressure is the absolute value, and the room temperature, 20 degrees. Okay, when I click that, opening is mean it can give you arrows with 2 directions. You see it as soon as I click OK, but I haven't selected the face. I select the face. And when I click OK, you see it's giving me now the 2 directional arrows, which is opening. It's mean the pressure can go either way. And you can see in the boundary conditions, it created the new one. It's called environmental pressure 2. So velocity and pressure, you see every time I click on them, they will highlight my boundary conditions. And they can show me the value if I want to see what I added there. And then the other one is showing me the value for it. So I can see every time. All right. That's the velocity. That is the pressure. When I click on the boundary conditions, they can highlight where I'm to make sure I'm in the right section. Okay. Now, the things I've done, I hide that tube because I don't want it to interfere with me. So I go back again and right click on the pipe. I say show pipe. For some reason it's not there. So I'll go under the boss extrude and click show. So you see the I say show, and then now brought the pipe again. And I go on the top, I say make it transparent, top level transparent. So I do what I've done before, so I can still see through. So now when I go to see the boundary conditions, you can see the pipe is back and the boundary conditions, I can see them through. Please save, always save. Because with CFD, crashes very common. The software will crash. All right, I'll go back to the CFD analysis. Here, goals. Remember when we started to say what we will learn today? This is the list. Navigate SolidWorks flow simulation environment. We did that. Define boundary conditions. We just did that. Now set goals for the CFD analysis. Goals is mean what you want the SolidWorks to calculate for you. What exactly you're trying to determine from it. So I come here and I right click on goals. There are different types of goals. One is global goals. Software design it and you just click and find the average values for them. Insert point, you want a point goal. Insert surface, you want the surface goal. Insert volume, you want the entire volume of the fluid. Or insert equation, you type an equation and the software will calculate that for you. So you don't need to do your own calculations. So we will start with the first one, insert global goals. Right click on it. I'll expand that tree. You see here, it's a minimum value, average, maximum, bulk average used for conversions, okay? So the first thing I'm interested here is to find the velocity average, X, Y, and Z directions for velocities. Also, I'm interested in the total pressure average value. So total pressure, average, velocity, average, X, Y, Z average values. By the way, if you're including temperature, you can select temperature. If you're including wall temperature, heat temperature, forces, if you want to study forces on the pipes as well, forces in X, normal forces, friction forces, shear stress impacting on the wall of the pipe, all of these things, you can select them, depends on your application, even if there is a torque. At this stage, we're taking the example, very simple. So when I selected that, I'm telling SolidWorks, target these values. Okay, so I click OK. You see generated for me goal 1, average total pressure 1, average velocity 2, and then the average for the 3 components of the velocity in the X, Y, and Z direction. Okay, so this is just a global. We haven't selected faces. Later, I'll show you how can we be more specific and select something. Okay. Global mesh. Meshing in CFD is easier than anything. Why do you reckon is that? It's easier than the FEA analysis. You never get issues with the FEA's meshing in the CFD because the CFD will mesh the box, the computational domain, that cube, and always mesh it as a nice geometry, not like going around. And inside is the fluid. So when I click on global mesh, edit definition, it's by setup 3. I will put it to 5. Not bad. And if you want to do manual mesh, that's if you want to do more specific, I would just use the automatic one. I set it to setting 5. Not bad. And click. The mesh will be all done in the calculation, not like the FEA used to be separated. Okay. Now, before running the results, I want to plot something. I want to do like some calculations. So what I would do, I'll go back again. I extended that to my geometry. I choose right plane, make it to face me, right? Sketch. I will sketch a line from that origin to that origin. Escape. I just sketch a line. I'll tell you what is that line, the purpose of it. It's a line where I want to draw the data on to see the velocity, how it's going through that line. Okay? Just a line. Line on the right plane. So how this line, it's actually inside the tube, inside the pipe. Okay, I want to sketch another line, but that line will be on front plane. But I would do some techniques with this one. If I click on the plane and control and shift it, the software will allow me to shift that and create a new plane. So there is a way of you create a new plane from that plane. I'll cancel this one. This is very important. Not many people will pay attention for this. So I selected that front plane, okay? So what I do, I click on control and bring the mouse the left, and then I start shifting. That kind of like to create a new plane, I'll give it a distance, let's say 500 in the middle of the tube. So now I created a plane in the middle here. You can see it. Yes, Shivam? Okay. So I go again, I'll repeat this again. So I come here and then I select the front plane. Click on control. And then I bring my left mouse, I click on it and then start shifting. Clicking control, holding the control and left click of the mouse. You see that is already generated for me the plan. I give that value for 500, which is tells me where to bring that plan exactly on the dimension. So it's here. Now, if I want to sketch on that plan, I say normal 2. Plan 2 is where I'm sketching. You haven't done it or done it? The control doesn't work for you because you're not doing right. You hold the control and you shift the plan.
On top plan.
Have you selected the plan? No, you select
So plan name.
and shift. No, you still control. You never release the control. Click control. Yeah. Shift.
And then it should show the plane.
You're not clicking the mouse.
Is it
Click both at the same time.
Did you not draw it on the?
Because you're on schedule.
It must have drawn it on a different plane. It's that one. It's that one. Right. Which one? When you hover over this, which one?
The steps exactly.
I think that I can.
Okay, so the plan, by the way, there is another ways you can create a plan from a plan. That's just the way if you were more like professional and fast, you use the control keys and things. You don't go and search for it. Now from that plan, I want to sketch a line. I'm sketching inside from that point to that point. Escape, and that is where is my line in the middle. I will delete that. I'll delete the plan. Looks like the plan is creating issues for everyone. So to create a plan, there's another way. Front plan, and you can search for it if you want to create a plan. You go to features and then reference geometry and you create a plan. That is telling me the easy way if you want to do it by things, and then you give that one 500 and you go through it and you can see the plan. So there are 2 ways. One is the basic way. The other one I'm showing you the control and hold the mouse is the fast way, which you go through it. And then I created that plan. And then I make that plan to face me. And then go to sketch, choose line. Remember, because my plan 3 is activated, so I'm sketching technically on plan 3. If you don't see plan 3 activated, it means you're sketching in different plane. So I click on that point and I go to that point and I created that line, which is kind of a line for the internal pipe. I check it to make sure I'm on the right. You can see it here. That is my plan 3. And that line is technically here. Save all the times when say save it so you can remember this going through it. Okay, it's just for plotting data. I'll show you later how can we do it in multiple times even after simulations. I've done with that. I go back to simulation here. Go back to it. Now everything is done. We come to results. Right click on results. Not results, sorry. We come to pipeline laminar, right click on it, and we click run results. Under running will appear for us a new window is to perform the simulation. You can see it here. I brought it here. I will select, it's preparing for me the simulation. This is to tell me what is trying to follow the setup. This is the goals I'm trying to chase. When they reach to convergence, this means the solution reached to its normalization and the try and error. And here I can see immediately the results step by step. So I select settings. Instead of front, we can use the right plan, and settings change to velocity in the Z direction. And then, okay, you can see the pipe with the study simulation for it. So that is technically that window is showing me how many total cells, the fluid cells, the iteration, try to solve the problem, the time will take to solve the problem, how much is taken from the CPU time. The calculation time left is about 7 minutes, but that is fluctuated, goes up and down. I'm using 4 cores from this computer. And as well, I can see initially the results showing here. This is not the results. This is just showing you what is in the background. The software is solving for me the problem. Later, when it's finished, it should give me a message, the simulation is finished, and then I go back to SolidWorks to check the analysis. Again, similar to FEA, don't touch, don't bother, let it go, and let it finish. Because if you annoy the computer, its system may crash on you as well, especially if you don't have a powerful computer. So till these goals were reached to the green, it's been the progress of their calculation. They reached to the average value, the software trying to normalize them. And when they reach to the normalization convergence, this means the solution is going to the right direction, then the analysis finished. So at the moment, it's showing the progress, but very soon we'll go through it as well. I can see the pipe. It's showing me the velocities, minimum and maximum 0.02 meters per second through that scenario. See, now the progress start getting 47%, 33. So that progress start changing. When I see them green, it means my simulations are done and finished. Yes. You selected the outside face, yeah. Select from the other side, inside. No, you're still outside. So inside, I select from that way. That inside. You're going behind, but because you're selecting wrong, so what you do, you need to remember the steps I say. You hide the geometry. So all of this, you miss them. So you bring that one, then you hide. That now you have that selection, that selection easy to do. So you select these columns out. Remember when I say you need to hide the geometry? All right, so this simulation now achieved. By the way, this will be recorded so you can watch it anytime and you can go through them step by step. If you haven't followed the steps exactly how I mentioned, then you may get things completely slightly different. So you really need to be very careful in following the steps. So again, the average total pressure is achieved after 135 iterations. Now trying to do the remaining of the results. That one doesn't have several. License for that one. You done? Oh yeah, you done the results already? Yeah, no, it's already done. You already have the result. You're redoing it now. So see now, it's average velocity Z direction achieved, 197 iterations, and average velocity is achieved 184. That one, of course. Okay, to select them all, select my top one, right? So, you already got them, so. Yeah. What? Where do you stop now?
No, I just want to run it down.
You want to run it? Have you set up boundary conditions?
Yeah.
Okay, you just come here and no, the boundary conditions. Okay. Station domain. Say something. Phase one is out of the configuration domain. So where is phase one? Where's your phase one? It's phase one. In the foundation condition. Oh, you have two phases. That's why. Right. Oh, you select both of them velocities. That one you selected the outside face. If you say the inside. That one is the inside. Not responding. Yes. Velocity, good definition. Why is still selecting the outside? Right, so I got the results now. So after this simulation is finished here, I would just revise this. First of all, I should make sure it's a solver finish. And again, depends on the processor, average velocity in the X and Y. The Z achieved that. Here is some of the important information. The time took for the calculations. It took about 355 iterations with 8 minutes, 25 seconds CPU time. And all those information when started and everything, they are already in the going through it. So now I go back to the SolWorks. SolWorks, when you see that, you see 1.fld, that is mean the results. And if remind you, if we go back to the folder where we saved everything, so for me under downloads, you see that folder already created for me the one and pipe. So if I click on one, you see the FLD. That FLD, that actually is the file which has the results, one FLD. And everything is inside and calculated everything. So never lose that. And that's why I say when you submit this for your assignment, you control zip everything inside. So people can load and unload. So when I come here, unload or load results easily. To save me time from rerunning the simulation, I just load your results and check them. And as well for you. Expand that tree, click on the plus. Let's do some resulting. First of resulting, I'll go to plot. Right click on plot, insert plot. You see here the tree, it tells me what we did. So I'll select the last sketch we did, that in a blue, in plane 4. I want to investigate the velocity in the y direction. So velocity, no, I want velocity in y direction, okay? And show will sketch for me the velocity on the y direction of the pipe, okay? Also, I can export this to an Excel file. Like you can see, show or export. And you can see nicely, you can get the Excel file for your velocity with the values, the length, and the sketch. By the way, the T is 20. I need to correct that. So when we reduce 0.2, so the internal diameter is 60 millimeters. Because the thickness was 2 and 2, takes from both sides of the diameter. All right. If you want to sketch the velocity, add another sketch. You see it adds another sketch here for you. If you want to sketch the pressure, sure, we'll add the pressure for you here. And if I want to show these, right-click on Xplot and show. They will appear here in my SolveWorks simulation. Just right-click on Xplot and click Show. If you want to hide Show to show them. XY plot, insert. I will sketch the other sketch, clear selection, and then velocity in Z direction. Show. That is the velocity in the Z direction. Okay, another thing I could do, it's cut plot. Right click on cut plot, insert. I need to select the right plane. So at the moment it's showing me this is the plane for cut plot. It's not really what I want to see. So I would change it to right plane. Right plane, I make sure that is in the center. If it's not in the center, I can move it right and left, but it's by default in the center. I want to show vectors. I don't want to show pressure. I want to show the velocity in the Z direction. So I could select multiple things here. I could change the size of the vectors, arrows, and then I'll just choose the vectors, maybe streamline if you could add, and then click OK. And that will recalculate for you to show you how it looks like the vector. Right click on cut plot, you can play, and you can see how the fluid is passing through the points. But that play, it's play between the cut plane, moving what's in the plane, right and left, right and left, right and left. Okay? So it's just showing you from one edge to the other edge of the pipe. To go from that end to the center to the other end of the pipe. Hide. I can go and do flow trajectory, insert, right click on flow trajectory. I wanted that to start from the front. So flow trajectory starting from front plane. I want it to be, instead of arrows, to be spheres. Velocity in the Z direction. I could make them around 40. This is velocity. I'm happy with that. And then click and will perform the calculations for me. And now I can see how these spheres will travel during the pipe. So when I come back here, flow trajectory, play, you see them, how they travel through the pipe. So that if you want to see how they go. Why do you think at the top and at the bottom of the pipe are blue? Because the velocity is almost close to zero. So there is something interesting about this sketch. The velocity should be starting from zero. So that's where things zero and the maximum is 0.01, or let's put it 2, because it's developed flow, and the minimum is 0. And then click that, and you can see the velocities at the edge of that tube. It should be kind of like reading 0 close to 0. And then the middle will be the maximum velocity, because this is how the contours will create for us. The laminar profile velocity. You can see the laminar flow is just going that way, 0 to the maximum. Height, stop and height. I don't want to show that. I could explore the isosurface. Insert. It's by default, it's choosing for me the velocity in the Z direction, global, and I click that, and then it's showing me that is how my isosurface of the velocity going through the pipe. So technically, that's how the concentration of the fluid. Okay, what else? We did isosurface, surface plot. If you want to plot the surface, that's usually when you have a temperature. You want to see the temperature on the pipe wall, but we don't have temperature here, so it's fine. We don't have, but we could see the pressure on the surface. So you could select outside and put it as a pressure. Failed because we didn't have anything on that surface. So that's, again, I'm just showing like you can choose it, but it's not showing me anything important because the application didn't take any pressure outside. If you want to show the mesh, insert, choose right plan or anything you want to plot, cells or channels. Didn't use any cells, but we're not doing any complicated mesh in this application. Yeah, those are the most important. Particle studies, this is very important if you're doing filtration system. So if you have a HEPA filter and you see how much particles, big ones, pass through the filter and they get reduced. We do some study later about it when comes time. Surface parameters, we can do volume parameters later. We have a hospital example to study some of the things. Again, so there are many other options. Props is very important. So if you want a prop, you can select anything you want to capture, copy image, print image, display what you want to display, 3D roller or timer, results, load from results, insert cat flow, XY, solver. So this is kind of like the tools. If you have a heat, you will have a heat source. We're not doing any heat in this example. Electrical features, we're not doing any in this example. It's just pipe and water passing through it. And we go through step by step. So that is technically the setup you get every time you go to this example. You see the file is generating more results and everything we do try to capture it for us. I want to do some cat plot, but small cat plots. Top is good. So ISO, stream, pressure, 3D plots you can do by parameter. Crop region. If you want to crop the region to show a small region, you can do that. So technically, you can reduce the crop region, how much you want to show So you follow the dimensions X, Y, and Z. So I could reduce that is already on 0. The blue ones. Okay, something like that. And then vector, not contours. And then we can see how it looks like. So this is a crop of a region just to show you how can I take a small region, not the entire pipe, to show the laminar flow inside. And I can adjust that to include more information relevant to what I'm trying. So if I don't want I could have the streamline and show how the streamline going through that region, not the streamline. I could change it to the contour, deactivate streamline, and you can see how that contour for that region. But I choose the pressure, so I should change it from pressure to velocity. In the Y, contour doesn't give me much. Stream, mesh, if I want to include mesh, transparent, velocity, fixed color. So that is kind of like I added the mesh to it, and I can see how this is very important if you want to study how, if this is a laminar or turbulent flow, how the flow is going with that nice profile. Report, you click on report. And you can generate a report, what the study is done. There are some templates for the reports. You just select one of them, create report, right click, and then it says new template or from template. So existing one, flow simulation report, okay. And then it's already saved when you downloaded the software. Now, based on that template, will generate for you a report similar to the one I'm opening now. SolidWorks flow simulation. I will avoid that report for the following reasons, because many people used it in the past, and Turnitin will show high level of similarity when you use this report. But if it's good, if you want to get the information from it, like the data we just got, the report will summarize them all and showing you nice things, what has happened from it. As long as you don't copy it, you just use the information from it. Because as soon as you use this one and try to amend, Turnitin will show that you have a high level of similarity because people use this report in the past. All right, so that is the report. Yeah, okay. So you see nicely, this is what you learned from fluid mechanics, how it looks like the laminar flow. So how can we check laminar flow profile? Quite sure you done in the fluid mechanics. We'll show you. Oh, internet's slow as well. So when it's laminar flow, you always get that shape of fluid. It's velocity going through that, and then the maximum will be on the middle, and the average will be whatever is the 0 to the maximum minus 0 divided by 2 or plus 0 divided by 2. We give you the average one, and that is what we call it, the laminar flow. So what you can see here nicely how you get that contour. So let me remove the mesh. It's a bit adding to it. Edit definition and click the mesh. You can click streamline and make it that way. Oh, it's worse. You need kind of like to explore with it. This. Yeah, that is the best. See how nicely you can see it. The laminar flow, especially when I zoom out, you can see how the profile, it's giving you that the maximum will be hitting in the middle, going through that parabolic shape. So again, this is kind of like everything essential on how to set up the software, the CFD analysis, pipe laminar flow. Let's say now I want to do another study, change something with it. So I come here like pipe laminar flow. You see this one? Right click, clone. So when I clone it, I will call this one turbulent. Again, I'm allowed to change physics. I'm not allowed to change the physical geometry, the shape of the geometry. To work in CFD analysis, you need to create a new SolidWorks files for a new pipe, a curved pipe or a pipe who got some change in the diameters. I'm only allowed to change the physics here, which is what we will set up. So when I click turbulent flow, it will generate for me pipe turbulent. Everything is saved there, boundary conditions and everything, but now I need to change the value. So what I would change here, right click on input data, general settings. Remember, we set it up to be only laminar. So I'll call it now only turbulent only. And apply, must click on apply, and then OK. Now, inlet velocity, edit equation. So instead of the value 0.1, let's make the inlet velocity 1 meters per second. Very fast. Click OK. That's all. I change software to understand this is a turbulent flow regime, and I change the inlet velocity to 1 meters per second. And now I just come here and say run. And then the software will run the study again for me. It will take time. And see it generate for me again the mesh capturing, preparing the geometry. We'll perform the analysis, and we'll start recalculating my goals, the same goals I set up earlier. And this picture should be appear very soon. And now you see this velocity, how it got. See, now it's getting red because it's trying to go to high velocity, 1 meters per second. And I will leave it for 10, 15 minutes based on this basic simulation. Some other simulations like the valve would take easily 1 hour. So that's, again, something you need to be patient with the CFD analysis. I always recommend you doing one computer something and then try to do studying or homework on the other. If you don't have other computer, you can just study, or if you have like in the lab, you can use one for simulation, one for doing other assignments. And that way you optimize your time. So again, let's solve it as a new step. Now, what will happen to the results? You remember it was 1.fld file. What do you think now after finish? What will happen to that resulting file? Will be called 2FLD. It's treated as result 2. And you need to change between them. Yeah, it's just renaming them. Yes, Shiva.
How do you make this one bigger?
So you click on computational domain, yeah, and now you extend the arrow, the flow arrow. Still, you're having issues with the boundary conditions?
Yeah.
Have you selected them right?
Yeah, it's just that part where this.
No, if you selected inside possibly, that's fine. Yes. Yeah, not talking about assignment.
Just one by
Yeah, not talking about assignment. Yep. Okay. Not talking about the assignment right now. Yes. Get that 1 meter per second, and then so again, when you see that calculations finishes between the blue line will end up going through the results. Any questions from the people online for this CFD analysis? How's going? Who we have? Oh, just Glenn and Prodi. How's it going? Everything is okay there?
Yeah, working on it, Mohammed.
Oh, good. That's good.
Yes.
Oh, it's a good rest. I'm recording. So now when you see that's finished, you see its file is changed to 2 FLD. So that it's mean the results. Now, if I go to the folder, you can see under experiments, creating a second folder is called 2. That it's represent for me the results for the second scenario I just put there, which is the turbulent flow. Everything is saved there, show, and we show you the results we produced previously. However, when you do XY plot, I don't recommend you show it again. You go and create a new XY plot because they may not, if you change some of the values, will show you the range very funny. So I'll show you an example. See, they don't show up everything. The scale has become higher and it's going and sketch everything on the previous scale. So I will not rely on that. I would just go XY plot, insert a new one. And then from that new one, I'll select, for example, sketch 3. And I want the velocity in the Y direction, Z and X direction. And I show, and now you can see the nice. But what is the most important, which I wanted to show you, it's this Z direction. That is the turbulence profile, which we're looking for. That is actually how it looks like if it's a turbulent flow. So it's showing you how nicely the flow regime, it's interestingly getting close to it. Comparing that, if I go back to the pipe laminar, again, that's another thing. So if I go back to my old simulation, it's showing me there is no results here. Right click, load results. By default will bring me the 1.fld because that's where to go through it. And now I go to my XY plot. I prefer always you create a new one and you sketch for Z velocity show and then showing it. That is the profile for laminar flow, the 0.001 meters per second parabolic shape. And if I go to the other one, which is the pipe turbulent flow, again, I think was XY plot, show that is the one I'm trusting when it's turbulent flow. That's what we learned from fluid mechanics. The laminar is parabolic shape, and the turbulence will be very close. If I go to Google to show you how they looks like, we'll study this in the next chapter, like when they go through it. So that is showing you like some of the fluids. So this is kind of like is a turbulent flow. This is a laminar flow for calculating Reynolds number. So that is the profile. This is when it's a laminar. It give you parabolic. Turbulent time average velocity will give you everything close to each other and going through it and very nicely. Yeah, there are many things. This is as well. Turbulent flow will give you that shape. Laminar flow will give you that shape, which is that what we are looking for in this result for a straight pipe. Okay. Flow trajectories, hide the cut. That's how it shows the flow trajectory. Everything is red because everything is agitated. There's a lot similar when you open the tap in your house and you find the water will come as a white color, not like transparent, because each particle is pushing each other and they're creating that disturbance flow through the tap. When it's have laminar, you open the tap very slow and you see through that it's a laminar flow because the fluid is going nicely and smoothly and the particles, they are transitioning smoothly on each other, not like this one disturbing each other and they move very fast, similar to this pipe. Okay. If I want to change the scale, right click on the scale here, and I can change that value to be 1 meters or maybe 2 meters per second, just to check any differences. Now you can see when I change the scale, it's showing me the distribution of the fluid because I'm going above the velocity I set up. I set up my velocity 1 meter, so I'm going what it looks like if it's 2 meters, my target, and go through it. But you know, our velocity in this example is 1 meters per second. And that's how it looks like, the 1 meters per second. Okay, so how can we get help with this software? Tutorials. So to come to the tutorials of this software, it's slightly different from what we learned from FEA. You come still here to help. Under help, you go to SolidWorks simulations. You see flow simulation tutorials. You click on it. It takes you to a website. That website got very interesting intermediate example. Where did I go? Determining of hydraulics loss. And that example, you follow it step by step by going next, next, and next. I'll give you that example and how to set up, how to read the file, how to set up your boundary conditions step by step, how to calculate the friction loss, and you go through it. This is very important if you're working on your assignment. Very similar to assignment 2, but not very similar. Like it's good start to learn on that first, and then you go to your assignment question. And then you finish from determining hydraulics loss, you can go cylinder drag coefficient. That one is not yet because that is external flow. The first one was internal flow. This one is external flow, so I will avoid cylinder drag coefficients. Heat exchanger is the one internal flow when you have two fluids. One is hot, one is cold. And the system we assume like will be isothermal or like a thermal temperature changes between them. So that is internal flow. Mesh optimization, it's how can you improve the mesh. And then you move to advanced examples, application of cooling of an electrical board. Textile machine, non-Newtonian flow and channel cylinder, radiative heat transfer, which is, again, very interesting examples. Rotating impeller, if you're interested in doing some fluid mechanics, advanced fluid mechanics. CPU cooler, like when you have a fan and it's cooling up. Oil catch can. And then my favorite area, which is the area I like and work a lot, is the HVAC modeling system. You have the 150 watts halogen, like if you want to do floodlights. Hospital room, that's when you have a patient in the hospital and they are breathing CO2 with viruses. How can you calculate everything or thermal comfort with it? Pollutants for a city, when you're trying to reduce the pollution for in a city, you can do it at a big scale, not just like for a buildings. This is important for city councils because part of New Zealand laws legislation, when you have apartments, The city council needs to monitor the particulate matter based on they have balconies, so people will not smell the exhaust of gases or VOC, like those things. So they do some analysis about it. So those actually my favorite 3 tutorials. And then they have examples for electronic cooling models, electronic components. You have this electric circuit boards, and there is a heat sink. You can see that heat sink, and you can do some analysis for the CPU heat pipe and how can you do it. Similar to the new computers, the new gaming computers, they have a water cooling system. That's also done by CFD analysis, because there is internal, and then how they can cool the CPU during these processes. And parametric studies, that's when you try to perform some advanced studies if you have heat exchanger, inlet and outlets, and regular valves between them. However, you say, okay, these all tutorials, where can I find the files? Like, where are they? So opening the model, they tell you by default, when you download the software, the models are already on your computer. So let's learn how can we find it. So when you go to your computer, go to your computer, must go even WinTech 1, this PC, C. I always forget where are they, but should be SolidWorks 25 SP. And then flow simulations. No. I forgot. Toolbox. Okay, I know how to find them. SolidWorks data, maybe. Lines, update. No. Okay, it's not here. Then it's program files 86. See, if we struggle, like me, I'm struggling now to find them, I go and search for them from the library itself. So I will say, for example, they have this one, B1 hydraulic loss folder. Okay, so I'll copy that one, B1 hydraulics, and I go to my C drive and search for it in the search, and hopefully that will give me the direction for it. No, I didn't search in the right place. Search under C drive or all C drive. Hopefully the ITS didn't delete it. Should be found. Have you found it? If it's installed on your computer, you should get them easily. But here, because it's not my computer, I can't find them easily. So I'm searching for them. It should be there, like when you can see them, B1 hydraulics loss. You found them, yeah. It's hidden somewhere. Program files, and because I have many, and I don't have admin rights, so I'm searching for it. I'm using the lazy way, which is just search for it, because this is not my personal computer. But they are there. Now, because that folder is protected, you should copy that and put it in a folder like the activity you want. Don't lose them, because they are there when you download the software. They give you the full library for them, and you go through it. Come on, find it, please. I hope they install it with it, because you need to tick that. Do you find it? Like I'm giving up on it, let's say. Should be very easy to pick up.
Mine wasn't in Windows, it was in
Program files.
program files.
Yeah. But I'm searching all, okay. Let's do it again. I'm searching. So here, program files, and then on program files, you find SolidWorks, Corp, and then, that one, and then flow simulation, and then examples, you get them all here. Yeah, that's all. So that is the pathway for it for you. If you install that software, your computer, your Windows C, program files, SolidWorks Corp, SolidWorks flow simulation, examples. So when you get the examples, for example, we want to work on B1, the hydraulics, or the ball valve, whatever. Let's say the A1 ball valve. Okay, I will do first, I will copy that, Control C, and I put it in my desktop to avoid any things to my C drive. Came the ball valve. I'll close my simulation, the one I've done. Don't save. I don't want to save my things. I'll come here, File, Open. I put everything on my desktop, the ball valve, and I click that, will bring for me the ball valve exactly how it is. Okay. Now, to go back to the tutorials, I will go first steps, the ball valve design. This is the first tutorial. Okay. So we'll be doing, I will minimize these so to not confuse you. When you click on help, how can I find this? You come to help, SolidWorks simulation, flow simulation tutorials. You go to first steps, ball valve design. And here it's telling you what we learned from that: opening the model, creating a flow simulation project, specifying boundary conditions, specifying the engineering goal, specifying mesh settings, running the calculation, monitoring solver, adjusting model transparency, view cut flows, view surface plots, view iso surface plots, view flow trajectory, viewing XY plots, viewing surface parameter, analyzing design variance in the valve, cloning the project. That's exactly what we did just today. But now instead of one part, you have a valve with multiple parts. Analyze design variance in the flow. So you will divide your screen to two parts. This is the challenge. One here, plane, and one here. And then you go from this, you see that next topic. You can minimize that. You don't need the table content. Just close it down. Bring that one here. Okay, and then you go next by topic. You read the instructions and you follow exactly. They give you images and how you set it up. And I want you now to give it a try by yourself, which will be something you will learn how to do it by your own independently. And that way you build your knowledge to try the other tutorials, okay? So I will pause the recording and we'll come back later to it. But I want you now to start on it. Give it a try. I want you to, yeah, again, upload your things to in-class activities and mixing flow analysis. And then next week we do as well another examples for internal flow. So we haven't done, we do 2 weeks for that topic. And then we will talk about introducing assignment 2. Now the remaining for this time, I will answer any questions if you have about assignment 1. Other than that, I will stop recording and end up the session, but I will have a space for answering any questions about